Everybody, welcome to IndEx Online webinar on EXT. What we'll be doing is covering the standard for EN, IEC, UL and give examples of what may be expected. At the end, you may ask questions and there will be polls throughout the presentation. For EXT, protection by enclosure or dust height, there are multiple applicable standards, but typically we use the EN IEC 60079-31. The latest edition of this standard is edition 2, which came out in 2013. There are other national deviations, such as the Australian version, and as well as the UL for US. UL version of 60079-31 typically has the most deviations compared to the others. When considering Europe, there has been harmonization to which standard is now being applied. Since 2016, the edition 2 has been applicable. When we look at the history of this standard, edition 2, which is currently harmonized between EN and IEC, it is applicable for ATEX, UKEX or UKCA, so Britain, as well as for IEC Ext. The last edition, edition 1, is no longer possible for use as of January 2017 for ATEX or UKEX, while IEC Ext allows up to one edition back. Now, the preceding standards before that were the EN standards in Europe and the IEC standards for international. Now, we are currently on the latest standard, 60079-31, edition 2. If you ever want to find out the history of these standards, you can go back to edition 1 on the IEC web store. When clicking on history, you will see which edition of the standard is valid, which one is also been revised or withdrawn. So edition 1 has been withdrawn and currently edition 2 is the valid option. So typical installations, what do we see? Well, we see installations that significantly have a lot of dust around. And usually data plates, nameplates that are difficult to read. And, well, examples such as this, a motor that is completely encased within dust. This is a very significant risk because it's acting as an insulating layer and causing the equipment to heat up. Then we have equipment without covers installed. Can everybody hear me? Okay. So typical industries in which we will see EXT be used. The most recognizable one for all of us would be coal industry. Within the coal industry, there have been significant events from the late 1800s onwards. We also have the grain industry and agricultural. We also have the wood, paper, and pulp industries. Sugar industries and other food industries. Once again, grain and our agriculture. This one would be synthetics, pulp and paper, metals, whether being refined, machined, or mined. This one is a hybrid facility where there was dusts and gases present. Then ones that most people don't think about, iron ore industries. Also, iron ore involved at foundries. Aluminium, very dangerous. There have been multiple explosions in the past at manufacturers for such as Apple iPhones. The machining process of aluminum dust is very dangerous. Then of course we get into the types of dust that do not require oxygen, such as the incident that happened in Beirut, ammonium nitrates. And this facility was pharmaceutical plant. So these are the typical industries in which you'll find these events to happen. Now, most explosions that seem to happen within dust industries are typically found within the wood industry. My mouse wouldn't act up. In the wood industry and the grain industry. Pharmaceuticals is also in here, but it is a industry that has multiple different possibilities because they do use a lot of gases, liquids that give off vapors. So typical industries in which we see dust explosions are wood and grain, food, sugar, metals is a big one. The most common that we automatically think of is coal, but there is also the paper industry, pulp, and synthetics. Now, ignition sources of dust. There are 13 potential sources of ignition. The ones that cause most ignitions are mechanically generated sparks, as well as hot points, hot surfaces, fires, friction, smoldering spots. So from mechanical failures, other ignition sources can be created, such as the hot surfaces and fires and smoldering points. Electrically, there is the typical electrical equipment, but also static electricity, grounding, earthing, and other points as that. So when we consider the 13 sources of ignition, we need to consider the dust pentagon. There's a requirement for an oxidant or oxygen, combustible dust, confinement of the dust, an ignition source, which there's potentially 13, and the dispersion of the dust. Now, let me know if you cannot see this video. So what happened there? Well, the firefighters actually caused an explosion. What happened is, if it would do it, they caused the dispersion of the dust. Wet dust is actually really conductive, and the flames easily spread between the dust particles as they were dispersed within the air. Therefore, an explosion occurred. Now, when we go into the standard, scope 1, this standard, -31, is protection by enclosure, which hereby protects the surface temperature limitation for the use in dust hazardous atmospheres. It has specific requirements for design, construction, and testing of the electrical equipment and components. The general requirements of -0, 60079-0 also apply. If there's any conflicts, this standard takes precedent. This standard does not apply to dusts of explosives, which does not require atmospheric oxygen for combustion, or to pyrophoric substances. So what that means is that in Beirut, the ammonium nitrate, while that is used as an explosive, it is also a fertilizer. It is a key substance that is open to interpretation and is controlled by, let's say, governments and industries which do not want it to be regulated under hazardous areas. Now, this standard does not apply to underground mines or surface installations which are endangered by fire damp, okay? The standard does not take into account the emission of flammable or toxic gas from the dust. In consideration for additional protection measures is required for electrical equipment which can contain combustible dust as well as gas. So what do we consider? We consider that a hybrid mixture. When you have a mixture of gases, vapors, and liquid gases and vapors and dust or fibers or flyings, when those two are together, that is defined as a hybrid mixture. Now, where the electrical equipment needs to meet other considerations, environmental consideration, such as ingress protection, resistance to corrosion, there's another requirement that we need to consider. Well, perhaps it needs to be greater than IP5X or 6X requirement. If there is a water ingress requirement, then the X would need to be defined. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, what is a hybrid mixture? Well, the actual definition straight from IEC Electropedia, it's a mixture of flammable gas or vapor with a dust. So if you ever want to find out the characteristics of your dust, you can go to ISO IEC 80079-20-2, material characteristics of combustible dusts test methods. And combustible dust means dust is defined as combustible dust and combustible flyings. Now, EPLs and zones. Where only the zones are identified in the area classification documentation, then the following relationships between EPLs and zones shall be followed. Within dust hazardous atmospheres, there are zone 20s, 21s, and 22s. Within a zone 20, only a EPL equipment protection level of DA, dust, A, are applicable, while in 21, DA or DB can be used, while in a zone 22, DA, DB, or DC can be used. Right now, we're going to ask a poll question. Okay, we will give it 30 seconds. Can everybody see the poll? Question is, what is the minimum IP rating of EXT equipment? Minimum IP rating. Give it another 5 seconds. 78% of people have voted. Okay. Share the poll results. So the correct answer for the minimum IP rating is IP5X, okay? The minimum IP rating of EXT is IP5X. X means testing of water has not been done. IP6X we will see where that is a requirement, but that's not a minimum requirement. IPX5 refers to water ingress only, while IP66 is the most ideal for a dust installation. Okay. Now, when we consider the groups of dusts, 3A, 3B, and 3C, the most dangerous is the conductive dusts, such as aluminum. That's 3C, while 3B are non-conductive dusts. And 3A are combustible flyings. The difference between 3B and 3A is typically the combustible flyings are bigger particles. The bigger the particle, the less dangerous it is. The smaller the particle, the more dangerous it is. So when we consider where the equipment, where the division is for that location, if it's a 2A, 3A hazardous area for dusts, then all 3A, 3B, and 3C are acceptable. While in a dust area that is defined as 3C, only 3C equipment is suitable. Now, the ignition temperatures, there are two different ignition temperature characteristics that must be considered. Layer ignition, where the minimum ignition temperature of a hot surface at which the dust layer ignites at 5 millimeters, but there are other considerations for 10, 15, 20, all the way up to 50 millimeters. Ignition temperatures with dust clouds are determined under a specific test condition. It is the lowest temperature of a hot surface at which a dust-air mixture, a cloud, ignites. Let's do another poll. Now, can EXT be used in a gas hazardous area? There are two answers, but one is most correct. We'll give it another 20 seconds. Okay, we'll share the results with everybody. So, can EXT be used in a gas hazardous area? Now, can you? Yes, but as long as you're not using that protection technique. Say you had a fluorescent light and it was rated for EXE, increased safety, and EXT. You would need to identify and ensure you're installing the installation to EXE. So the first answer is incorrect. The answer of no is correct, but is not the most correct answer. It is correct, but there are instances, if you put the answer of only if hybrid mixtures exist, that means no, but only if. So the answers of no or only if hybrid mixtures exist, both those are right answers, just one perhaps more than the other. And then the answer of yes for non-electrical, that answer is incorrect. So when we get into the -31 standard, EXT is divided into 3 levels of protection: TA, TB, and TC, which correspond with the EPL. With the EPL, we can see that TA is good for dusts A, zone 20. while TB is good for DB and TC is good for DC. Now there are construction and marking requirements for each one of these. TA is more stringent. There are failure modes in the industrial standard for particular components that shall be taken into account when considering applicable fault conditions. So 4.2, groups and ingress protection. If we consider a dust group of 3A, if it is a zone 22 or 21, IP5X is acceptable. But if it was a zone 20, IP6X is a requirement. So the key considerations of when IP5X are considerable is when it's a 2A dust, 3A dust group and a zone 21 or 22, or 3B and a zone 22. Remember, these are the minimum IP requirements for EXT, but typically a manufacturer would give you IP 54, 64, 65, or 66. It makes the most sense, perhaps, for them to sell their equipment where it is flexible for use indoors or outdoors. So, where IP5X is required, all enclosures, including rotating machines, shall satisfy the test and acceptance requirements of the IP standard 60529. We have 2 videos on IP ratings. Feel free to watch them to learn more. Any grease in the joints, well, they won't be used for IP testing. But consider the IP54 is a good minimum for manufacturers and for designers and selectors, procurement, while IP66 is perhaps the most practical piece of equipment to choose. When we consider TA, there are fault conditions that must be considered, such as the prospective fault circuit current shall not be greater than 10 kA amps. Where it is less than, it shall be marked accordingly. The maximum surface temperature needs to be followed as per 60079-0. The highest measured temperatures shall be the basis for the maximum surface temperature. That maximum surface temperature is then compared with whatever dust is being used in the facility for its ignitable layer temperature and cloud temperature. As long as the component's maximum surface temperature does not reach those temperatures, it shall be considered safe. Overpressure testing also needs to happen, where an internal pressure of 4 kPa is applied to the enclosure in accordance to the dust exclusion test. Dust exclusion by the enclosure shall be carried out in accordance with 611, where the IP testing confirms this. Protective devices, if the electrical equipment is capable of exceeding the surface temperature as a direct result of the temperature test, a protective device is required. A protective device may be integrated or external to the equipment. Where it is not included as part of the manufacturer, by the manufacturer as part of the electrical equipment, the marking shall include the X, conditions of use. The protective device shall be capable of interrupting the maximum current of the circuit in which it is installed. If the electrical equipment contains a battery or cell and a control device is provided to prevent the overheating of that, the control device can be considered a protective equipment. There are also then requirements for thermal protection devices and protection for arcing and sparking parts. Key point for EXTA, IPX6 is required. Now, when we consider EXTB and TC, the marking, once again, shall be the maximum surface temperature at which it can go up to, while there also must meet the requirements for testing of 612, with no dust layer on the external surface under normal operating conditions. The internal pressure of 2 kPa will be applied to the in accordance with the testing requirement, where there will typically also be an O-ring in a groove. Dust exclusion test will also be done. We'll ask another question. Can the components within an EXT enclosure or light or motor, can they be freely swapped? Can you replace a terminal? Can you replace a light? Can you replace the windings? What conditions? Think about the conditions that you must follow. So an EXT control panel, let's say from Stahl or Bartek or others, would have many devices within it. Give it another 10 seconds. We got 68% of people have voted. Okay, very good with these answers. So the correct answer is typically no, but the most correct answer is only as per the manufacturer's instructions. So if you have the bill of materials and the general arrangement drawing, typically it would list every part and component down to the terminals, fuses, nuts and bolts. Most ideal, do as the manufacturer tells you. If you do not have the manufacturer's instructions, don't change anything. If you need something repaired, send the device to a certified repair facility, such as an IEC Ext certified repair facility under the service facility scheme. Okay, the joints. So the face between the surface enclosure or the cover and the body of the device. All the joints of the enclosure, whether permanently closed or designed to be open from time to time, shall fit closely together within the tolerances specified in the documentation. They shall be effectively sealed against the ingress of dust, and probably water too, and shall comply with the particular requirements subjected in the testing requirement of 611. The use of grease alone to maintain the integrity of the seal is not considered to satisfy this requirement. Now, threaded joints. The number of threads of a threaded joint employing parallel threads without an additional seal or gasket shall not be less than 5 threads of engagement with a tolerance as per ISO 965-1. Threaded joints, tapered threaded joints without an additional seal or gasket shall be no less than 3.5 threads. Now, interesting point. 5 threads of engagement for parallel threads in 60079-14 give you IP54. For dust, it gives you IP64, interestingly. Tapered threads, the same. So if you're thinking of using a conduit system, be advised that the use of grease or tape or an IP washer is considered not needed as per this clause, as well as 60079-14, clause 10. Now, hinges shall not be used as a means of maintaining a seal unless the correct compression of a gasket is achieved without undue movement, stress, or distortion of the gasket. So the most important thing of EXT, protection by enclosure, tightness, is the use of a gasket, okay? They are manufactured from materials that would not affect the correct function of sealing. So consider the external ambient conditions, such as corrosive substances, also liquids, and other impacts that may be had on an O-ring. Where necessary, a means shall be provided to facilitate correct alignment of the mating parts. So sometimes you'll see an enclosure with guiding posts, and it helps make a proper connection. Now, gaskets and seals under compression in joints may be used to ensure the effectiveness of the enclosure sealing. All gaskets and seals shall be one continuous piece. They cannot be cut and placed. One-piece construction also ensures the gasket and seals have been permanently joined to form an uninterrupted periphery while maintaining the mechanical properties of the gasket or seal materials. Unless all gaskets are secured to one face, mating face, either by adhesion or mechanically secured, the design of the enclosure shall be that the gasket are correctly positioned, except for slight amount of lubricant necessary for the adhesion material on one side of the mating surfaces. Joints using gaskets shall not be supplemented by the application of a sealing material. Now, a flexible seal, such as a bellows, shall be such that it shall not be overstressed at any point and shall be protected from mechanical damage and secured at each end by mechanical means. These requirements do not apply to internal seals of cable glands. When we consider cemented joints, they shall not be used on mating parts which need to be removed or gain access to field wiring or in-service adjustable facilities. Operating rods, spindles, and shafts shall have openings in the enclosure where their ingress protection is maintained. There are then other requirements such as for windows that are either cemented or gasketed into place. Now, cable glands, 5.2, where the integral or separate, whether they are integral to the equipment or separate, they shall meet the requirements of 60079-0 plus the jointing requirements of 5.1. In addition, the cable glands shall meet the requirements of Table 1. But threaded cable entries may be EX equipment cable glands, or they may be tested and certified as a component of the overall assembly. Cable glands with other thread forms to those specified may only be evaluated with the electrical equipment or as a EX component. Now consider the table from 60079-14, Table 10, selections of glands, adapters, and blanking elements. So when we consider the glands, adapters, and blanking elements of EXT, where they can be used, they can only be used in dust environments for EXI dust environments, EXP dust environments, and for EXT. So when we consider the protection technique of the equipment, EXT only accepts EXT glands. So if you have a dual use fluorescent light that is EXE and T, typically you will find a gland that has multiple certifications. It is very common to see an EXDE gland that also has T and perhaps an R. Entries. The clearance holes shall have a diameter of not more than 0.7 millimeters greater than the nominal diameter of the threaded entry of the gland. So they must be very tight, showing the dust tightness. Threaded entries for TA, TB, and TC. As we can see, there is a problem in the standard where they said tapered threads shall not be less than 3 threads. That's actually supposed to say 3.5, where parallel threads shall be minimum 5 threads of entry. Where less than 5 threads of entry have been used, there is the possibility for that if the additional seal is considered and is done during testing and certification. And it will be denoted with an X in the certificate denoting the conditions of use that to those requirements. Type tests of dust exclusion by enclosure. General. The sample shall be subjected to thermal endurance to heat, thermal endurance to cold, impact testing, and drop testing if applicable. If there's other requirements, then there shall be no damage to the supplementary enclosure caused by the impact testing during the hot testing and cold testing. So that impact testing will happen during that cold and the endurance to heat testing. For protection of TC, the test of enclosure requirements to 60079-0 are modified for the thermal endurance to include to heat to preconditioning test to replace the 20K above service temperature with only the requirement of 10 Kelvin above service temperature. After conducting these tests, it shall be subject to the IP testing and pressure testing. So there's supplementary impact requirements, such as dropping a 1 kilo mass at a height of 0.2 meters. The pressure test, the main difference is it's at 0.4 kPa, 4 kPa plus or minus 0.4 for TA equipment and 2 kPa plus or minus 0.2 for EXTB and TC. Once again, the importance of the O-ring or gasket. IP ratings, we've gone over them, minimum IP 5X or 6X. Thermal tests shall be carried out in 60079-0. Now, routine tests. There are no additional routine tests required for EXT. Marking. These requirements supplement the requirements of 60079-0, which are applicable to EXT, TA, TB, and TC. The symbol for protection by protection use shall be TA, TB, or TC. Where the electrical equipment is suitable for a maximum rated prospective short circuit current of TA, electrical equipment at the supply connection to the electrical equipment of less than 10 kA, the prospective short circuit current shall be marked. So once again, it's controlling the temperature of the equipment. So these are examples of what we'll see for marking. When we're out in the field, this is a coal shed for a power station. This manufacturer has marked this enclosure, this light, I should say, as EXNR and TC. So we see GC and DC. This equipment is rated for a gas and dust hazardous area, which is very important in a coal installation because this is a hybrid mixture. So unfortunately, they did not mark the T ratings here, but you'll see below where we find it. Now, IP ratings are not a requirement on the line for gases. I completely disagree with that, but unfortunately, it's not in the standard yet. But for dusts, it is a requirement. So what we see here is this is EXTC, 3C, temperature class to be defined, DC IP66. So that we know that IP66 is good for the gas environment and the dust environment. So when we go down here, they then show you what wattage lamp you are choosing and what gas group you can consider based on your ambient temperature ranges. If we're looking at an ambient temperature range of -40 to 55 Celsius, let's say this is the Middle East, we will take 55 Celsius. If we were to use a 120 watt lamp, we would be looking at this line. So for in the gas environment, we would consider T5, And for the dust, we would consider a maximum surface temperature of T95 Celsius. On dust equipment, it is marked with the actual Celsius, the temperature rating. Whenever there are differences in process temperatures or ambient temperatures, you will typically find within the certificate or on the data plate these differences. If we were only considering 40 Celsius, we would consider that the equipment would only get up to a maximum of 80 degrees Celsius for dust, even with a 300-watt lamp. Now, what about non-electrical? Well, ISO IEC 60079 80079-36 EXT, the protection concepts for D, P, and T are based respectively on the types of protection for electrical equipment. So EXT, all the technical requirements apply. The nature and ignition sources of non-electrical equipment shall be considered when applying the protection of EXT to non-electrical equipment. So yes, EXT can be used by manufacturers for non-electrical equipment, which is basically defined as protection by enclosure, dust tight, IP5X or 6X, ensuring that the surface temperature does not get anywhere close to the ignition temperature of that dust. So if there is a requirement such as for a gearbox or a valve, for non-electrical, EXT is a potential solution. One last poll. Do components within EXT need to be EX rated? Inside. Components within, inside. Think of terminals, transformers, lights. This is an interesting one. There's almost an even split, so I'm going to give it till 90% of people vote. Or give it another 10 seconds. Okay, very interesting results. It's split down the center. So when we say within, perhaps that is open to interpretation. Within, we mean not penetrating the wall of the enclosure of the device. If we consider the terminals inside do not need to be EX rated. They only have to be industrial rated. So the IEC standard for that, if we went back, we will find that, the constructional requirements. Basically, anything that penetrates the wall does need to be considered, but anything within only needs to be considered as per the industrial standard, okay? Where the external protection, one second. We'll come back to that. So once again, anything that's internal does not need to have a U certificate, does not need to be an EX component. Anything that is making penetration through the wall or is an assembly with the equipment on the outside shall have to be EX rated. Now we'll open it up to questions. If anybody would like to ask any questions, you can type it in the chat. When did DIP stop being common? That would typically be around 2009 when edition 1 of 60079-31 first came out. Around that time, they started to define dust protections as they then took EXM, I, T, and P. So EXM can be on gases or dusts, or actually group 1, mining fire damp. Then there was also EXP, which can be for enclosures or rooms, but also for gases and dusts. Then there's EXI, which can be for group 1, group 2, and group 3, so fire damp, gas, and dusts, while EXT can only be used for dust environments, but can also be for electrical and non-electrical. Somebody's asking for a video on intrinsically safe. That would typically be about 4 different videos. In EXTB, protection with EPL's DB, is it one fault needed to be considered? So when we consider TB, it's not faults. You may be thinking of intrinsically safe, where there's the need to consider maximum of 2 faults for IA, 1 fault for IB, and 0 faults for IC. So when we consider the construction requirements of TB, there's a maximum surface temperature under normal operating conditions, an overpressure test, and dust exclusion test via IP rating. An example would be an LED light with protection EXED. You'll sometimes find that EXD devices are also EXT, which is pretty easy to meet because EXD already has an overpressure test and will be minimum IP54. So if the IP5X is met and the temperature, maximum surface temperature is met, EXD will typically handle those impact protection tests. Now, if it's an EXENT device, typically that device will not be as robust as the EXD, but both of them can be EXT. When conduit enters an EXT equipment, would you fit a conduit sealing to meet the requirement of 60079-14 clause 9.4? That's an interesting one. It depends on the installation. In Canada, when it comes to EXD, we always have a barrier gland or conduit seal, no matter what. Now, typically you would only have it where there's an arcing device inside the EXD, and then you would consider using a conduit seal. Now, EXT, the consideration you need to make is there potential for dust to travel up the conduit? Is there potential for pressure piling to happen? If you have 100 lights in a row with the same common conduit system, no, there is no need for conduit sealing. As long as IP5X or 6X is maintained throughout, that is sufficient. Conduit systems are a very interesting item that many people do wrong. It is a very common system to use in Canada and America. And where I come from and left many years ago, we continued to use it. But we use cables more often than East Coast Canadians or certain areas of the US. Would I install a seal? If I'm close to a zone 20 or the equipment is in a zone 20, yes, definitely I would use a conduit seal. If it's a zone 22 everywhere, typically not. It's more of a risk assessment method. need to consider where you transition between different types of zones and have a bit of common sense. Old dust marking is allowable? No. EXTD is no longer allowable, okay? So the old standards for IEC reference that up to one edition back is allowed, which was the -1 standard. The edition 1 standard. So I do not have that version of the standard. If it still says EXTD there, the only possibility you can use that is for IECX. Any equipment that is currently put on the market should meet the latest requirement. Anything that is existing on the market before 2013 may still have that old marking, okay? You can keep equipment on the market with the old markings if you're not doing any updates. But are those manufacturers doing themselves a favor or the best for their business? Typically not. If a selection or procurement engineer is going to select equipment, they're going to select something that they understand and meets the latest standards. If something's marked PID, chances are nobody's going to understand it. When gas dust markings are on separate lines, is it acceptable for hybrid mixtures? Yes, they have to be on separate lines. They must, they shall. And the whole point is to not cause confusion. But not all manufacturers mark things the same way. So you need to understand that there are differences. So if we go back to the example here, Warham did a really nice job and have 2 separate lines. The temperatures, they did say refer to table here. So it was really good. As Tom Waite said, yeah, a seal. When transitioning zones, you should use a seal. That is correct. If you inspect a grain silo, 50 to 70 years old, and the equipment was not rated, but is connected with conduit, and you felt based on a risk assessment that you did, that the IP rating was maintained, would you submit a failed inspection sheet? An old installation has to be inspected to those standards that were applicable at that time. Myself, I would do a risk assessment to ISO IEC 80079-36 and compare the 13 sources of ignition. I would consider industry past experiences, explosions that have happened, and look at the failures of items. If we're talking EMT or intermediate conduit, I would not be very confident. Then if it was rigid, it is much more robust. But the need to check for corrosion and other signs of degrading of the conduit would be very important to do. Perhaps the equipment is at its end of life. The best thing to do would be a complete overhaul and replace everything at a certain point. If you had lights in there, let's say, typically you wouldn't within a silo, but how much energy are they using? They are an ignition source. Perhaps you could change to LED. Perhaps you could find something that is still sufficiently robust, would lower their electrical bills. So there's different requirements. Also, as Tom Waite said, you would also consider the housekeeping of the installation. Yes, the buildup of the dust on the equipment. Also, the layout of the facility. Are there buildings within buildings? Are the roofs flat surfaces? Are there other flat surfaces for dust to land on? If there was walkways with no holes, that's dangerous because dust is layering and getting kicked up as people go along. So there are different structural and mechanical requirements where good design of a facility is really important. Give it another 30 seconds if there are any other questions. So once again, This installation was a conduit system for multiple lights. So with conduit boxes and also lights. Gary, thank you for the many thanks. Hope it really does clear up a few points. So we'll go back to gaskets and seals, joints, overpressure. So once again, the only requirement for EXT, gentlemen, is IP5X or 6X. The equipment inside only needs to be industrial rated, okay? Anything that protrudes outside goes through an entry. Anything that goes through an entry shall have to be EX rated, okay? If anybody has any further questions, feel free to contact us at any time. Our email is at the bottom throughout the presentation and our websites. We're here to provide owners engineering should anybody ever make that request. We're there to help anybody provide solutions to project overruns, to reduce cost and schedule overruns. We thank you for your time and we hope you have a very good day. Thank you very much.